So, hello everyone. My name is Bishan, and to fulfill the last part of my master's degree in GIST, my final capstone would be looking at analyzing land cover change detection from 2013 to 2020 in the Colville National Forest, Northeast Washington State, America. So here's a quick agenda I will be looking over. First of all, introduce to put some context behind the problem on why this project was needed. Then to introduce to the study area. After that, we will go over some objectives that I had quickly kind of run through the methodology and show the steps and my workflows. Then we will look at the results produced from the analysis. After that, it kind of goes over the conclusions. So the acknowledgement and questions at the very end to show. First, introduction. So this is my introduction to why this project is needed. Over the last 2 decades, the Colville National Forest changes in the spatial frequency and the structure of land cover types. Therefore, analyzing it could be a protection of the region and its communities. The study describes how human activity and the natural process in northeastern Washington may influence land cover over time and provides the description of the nature, significance, and the rate of change that can inform adaptive management planning in the region's federal lines. So let's look at my study area. As you can see, it's a large tract of land. And the area is about 1.5 million acres. It's a mix of federal and privately owned land, with around 120,000 residents living in surrounding communities. The tract of land includes city, Indian community, and tribals, such as Spokane tribal. The wildlife, and lakes, rivers, and the streams were also included in this study. We can reach along the Columbia River to arrive in Canada if you want. So the present data about the study is giving secondary information. Data sources include various governmental organizations, USDA, distributed and the published source. Landsat satellite images, which from 2013 to 2020 were downloaded from USGS official website. Every satellite imagery represents the summertime, which from June to August, like the image shows. Method. On the right side, I would like to talk about the method flowchart. After data collection, I would like to set up my study area by using a satellite imagery map. The first step of processing is a development of classification. Next, to supervise the classification technique way. Then calculated the classification accuracy assignment. The land use and changes detection by area calculation, and calculate the percentage of changes. Then get the result and compare and contrast the result, and we can verify the guys. Let's be specific to talk about the processing classification method, the supervised classification I used. Overall, the software used for this was ArcGIS Pro. The land cover classification from 2013 to 2020 choose supervised classification raster and create training data, which I created 6 classes, which could included in forest, grass. I can show the image to you. Forest, grass, urban, background, water, and red forest. And each class was selected 50 samples of training data. After training the computer, I used the correct training the software to kind of tell the difference between land cover classes. I use it was a support vector machine classify, make the map shows the right side, which is pretty powerful to assign classes based on the data that I was giving it on some referenced array-based map imagery and Google imagery, as well as NDVI index. Therefore, their surface reflectance to show what's covered data and what's not covered data with this. NDVI the NDVI we usually use a formula near infrared right divide the near infrared plus right. Because all the data I use is line side 8, so the formula is changed to band 5 subtract band 4 divide band 5 plus band 4. And to get the difference between 2013 and 2020, that can use NDVI 2013 subtract NDVI 2020. Or you can also find or download the NDVI image on USGS Earth Explorer. After the land cover were created, I access the accuracy with a strategy which following process to use feature to raster, cone tool, mosaic to new raster, set null, create accuracy assignment point, open attribute table and check the change, and check the change the grand truth number by one by one to check the difference, then to get a validation matrix. So below are formulas about how to calculate overall accuracy. On the left side, there are 2 tables about accuracy results, and I will talk about those later. For land cover classification used for them, the second step was to use those to combine them. So there's 8 years, which from 2013 to 2020, and the 2013 as a base to combine each of other years, like the images shows, to get the 7 maps. We can generate area of different pixels show what classes have changed over time. For example, from forest to grass, urban, background, water, or red forest. And according to the results after combine, we can find forest was a kind of main change. And I was looking at its quantified breakdown and covered into acres, then calculate how much percentage of land had changed. So here are the kind of results of the combined classifications. So we can see the forest class is the most significant change in decrease. And after annual change, after calculated percentage of annual change, we can predict how much area will change in the future. So overall accuracy range from 66.3 to 55.6. Forest class accuracy range, producers 48 to 47, but the users 93 to 74.5. Grass class accuracy range, the producer get 58 to 36, users 67 to 40. And Sun background class accuracy range, the producer got 63 to 51, users got 66 to 53. Forest grass and sand background are the top three with the most significant accuracy gap. The results satisfy random sampling method. As a result, forest has changed the spatial frequency and structure of land cover type. Forest has the biggest decreasing change. Forest class to background class decrease 36.4. Forest to forest decrease 34.9. Forest to right forest class decreased 31.5. Forest to water class 16.5, and forest to grass 13.8. Forest to urban class 12.1. So we can get the grass class is the second rank of change, and the sand background class is the third rank of change, decreasing change. Water class and urban class are all increasing. So I made another chart image. You can see the percentage of land change between 2013 to 2020, and to see how does it change clearly, that we can find the forest class all shows decreasing. On my conclusion, the spatial frequency and structure of forest land cover types changed a lot. The overall analysis found that over human influence was the primary cause behind the change. And we can find people's needs are increasing. The continuous expansion of the city, the demand for trees is faster than growth. For my future study, I would want to be looking at a future land cover prediction, because I have collected data that may help a little bit in the future study. And I will field visit the Colwell National Park and the surrounds. I would like to be specific research on evaluation process of the cities surround the national park, and analyze how it will evolve in the future. And I hope making a joint project which planning through the population, economic growth, climate change, climate conditions, common local disasters, but those may need other friends who study in those areas help. Acknowledgement. So I would really thank you for Dr. Fernando and Andrew's help. Thank you guys, helped me a lot on my study. Thank you.